Today again we will start with zeolites. Okay, so zeolites. What are zeolites? Actually, they are shape selective catalysts, and its general formula is actually M exponent AlO2 X SiO2 Y ZH2. Here N is charge on the metal ion. N is charge on the metal ion. X and Y number of alumino, number of silicates, SiO2, and Z is number of water of hydration, and they are variable. Okay, depending on temperature, pressure, all that. Okay, so actually zeolite is obtained from SiO2. See, this is SiO2. This is SiO2. Now in SiO2, alternate silicons are removed by aluminum. So now it becomes SiOAl three-dimensional framework. There is a three-dimensional framework, and as silicon 4 positive is replaced by aluminium 3 plus, it acquires negative charge, and to balance it, sodium, potassium, calcium, magnesium like ions are attached, right? So such are known as aluminosilicates. Actually zeolites are aluminosilicates. They are aluminosilicates and they have cage like structure. See, these are the cages, honeycomb like structure actually. And in these spaces there are water molecules. There are water molecules. And zeolite, which is to be used as a catalyst, they are oxide catalyst actually. So to use it as a catalyst, it should be first boiled, or we can say it is heated. When it is heated, water is removed. So these cavities become vacant. These are the cavities, and size of these cavities varies from 240 picometer to 740 picometer. Okay, and in these cavities a reactant which is small enough to enter this cavity and can easily leave this cavity can be accommodated. If size of the reactant molecule is bigger than this cavity, then it cannot be entertained by the catalyst, right? So the reaction which is catalyzed by reactions which are catalyzed by zeolite depends on size and shape of reactant and product as compared to size of cavities, or we can say pore size. That's why it is called shape selective catalyst. For example, ZSM5 is most commonly used ZSM5 is used to convert alcohol into gasoline. Gasoline means petrol. Okay. So what it did, alcohol first it is dehydrated by ZSM5 and we get mixture of hydrocarbons. And you know mixture of hydrocarbon is gasoline, which is also called petrol. It is small hydrocarbons which are gases. That's why it is called gasoline. Under pressure it is liquid. Okay. So alcohol turned into gasoline by ZSM5. Very very important zeolite. So this is all about zeolites. These are actually microporous structures. And pore size, porosity of the zeolite decides which reaction it catalyzes. Okay, that's why it is called shape selective catalyst. Okay, तो zeolite हो गया. नो ऋषि नो क्या? तो ये जियोलाइट समझ में आ गया सबको? Okay. Now come to enzymes. Next part is enzymes. So enzymes are actually biochemical catalysts. They are obtained from the living processes, living beings, or synthesized. Okay, but mainly they are catalyzing biochemical processes, and these are actually globular proteins. These are complex nitrogenous, because nitrogenous base is there, complex nitrogenous biomolecule. ठीक है, ऑर्गेनिक कंपाउंड ही होता है और कॉम्प्लेक्स होता है पूरा, है ना. और इसमें जो है देयर आर एक्टिव साइट्स. क्या होती है? एक्टिव साइट्स विच आर ऑफ पर्टिकुलर dimension, उसका particular एक shape होती है. Active site has a specific shape and size. That's why one enzyme which can catalyze one reaction cannot catalyze other reaction. It is specific for every reaction. So there are almost 3000 enzymes in human body, and if they were not there, even one meal taken by us cannot be digested in whole life. So enzymes are very important, right, as far as human beings are concerned. Okay, so enzymes are biochemical catalyst. They are used to catalyze biochemical processes. Okay, बायोलॉजिकल जितने भी प्रोसेसेस हैं, बायोकेमिकल रिएक्शंस हैं, उनके लिए हमें एंजाइम्स की जरूरत होती है. फॉर एग्जांपल, इन्वर्जन ऑफ केन शुगर. Inversion of cane sugar. Cane sugar means sucrose. Sucrose is C12H22O11. So hydrolysis of cane sugar, it gives C6H12O6 plus C6H12O6. That is, sucrose gives glucose and fructose. And which enzyme is used? चलो आज तो आप बोलो खुद, एंजाइम कौन सा यूज होता है, बोलो. Very good. Invertase enzyme is used. क्या यूज करते हैं? इनवर्टेज. वेरी गुड. enzyme used is invertase. Now second, conversion of glucose into ethyl alcohol. Yes. Which enzyme is used here? Follow jaldi. Prince, Ashish, good. Second का बोलो. Glucose to ethyl alcohol. C6H12O6. To give ethyl alcohol and carbon dioxide. बोलो. Okay. Which enzyme is used? Yes, tell me. Very good. So we use zylase. Okay. Third, hydrolysis of starch. Okay, conversion of starch into maltose. Okay, starch is polymer of this repeating C6H10O5N. When hydrolyzed, we get C12H22O11. Do it. What is the enzyme used? Tell me. Yes? Anybody? No. Last time you did it wrong. Maltase is used for what? It is used for to convert maltose into glucose. enzyme is used. Okay. Now conversion of hydrolysis of maltose, ठीक है, into glucose. To convert maltose into glucose, we use maltase. C, ये दिख रहा है? Okay, C12H22O11. On hydrolysis, we get 2 moles of C6H12O6, and enzyme used is maltase. Okay. Now conversion of urea into ammonia. Decomposition of urea into ammonia and CO2, because you know it is NH2 C double bond O NH2 urea, ठीक है ना, C NH2 CO NH2, right? So on hydrolysis it gives ammonia plus carbon dioxide. So tell me, for that purpose, which enzyme is used? If you are from bio background, yes, simple urea. So keep in mind it is urease. 2NH3 gas and CO2 gas, right? 6CO2. Okay, right? Now conversion of protein, okay, protein into, okay, very good, protein into peptides, and conversion of protein into amino acids, conversion of milk into curd, yes. So what are the enzymes used? बोलो. बोलो. Conversion of protein into peptide, कहाँ पे? प्रोटीन को पेप्टाइड और प्रोटीन को अमीनो एसिड में, इसको इन स्टमक और अमीनो एसिड इन इंटेस्टाइन. सो इसके लिए वी यूज पेप्सी. Anybody answered? Very good. Good. Very good. And this is for milk to curd, lactic bacilli. And what about protein into amino acid in intestine? Yes. trypsin, pepsin, trypsin, and lactic bacilli. So 8 enzymes out of 3000 you should remember. Okay, so it is not a difficult task for you, so do it. Now come to the characteristics of enzymes. So characteristics are of daily life, so you should add and I will write. You should write in the chat box and I will write on the board. So start. First, you will write any one. Yes, first property. I thought chalks are finished, but there are chalks, okay? So start karo. First is specificity. Can you explain specificity? As I told you that each enzyme has a particular reaction to catalyze. It cannot catalyze other reaction. For example, if we have C12H22O11, this is the formula is same. This is maltose and it gives glucose units, 2 glucose units. This is sucrose and it gives on hydrolysis it gives glucose and fructose. So for first reaction to convert sucrose into glucose and fructose, we use invertase enzyme, right? Invertase we are not using, but invertase enzyme catalyze this hydrolysis. But same invertase cannot catalyze hydrolysis of maltose. Though their formula is same, though reaction is hydrolysis reaction, same type of reaction, but here invertase cannot do the thing, cannot catalyze this reaction. So we should use maltase. Vice versa, maltase cannot be used here. So that means they are specific for a particular reaction to catalyze. Okay, that's why this is called specificity. That each catalyst, each enzyme has its own task. He will catalyze only one particular reaction. Okay, right. Next, and there will be only one enzyme for it. Very good. Another characteristic, is efficiency. Efficiency means, what do you mean by efficiency? They are highly efficient. Enzymes are highly efficient means what it means. Yes, tell me what it means. Output input right, means output is greater than input, but that is the concept of physics, or we can say thermodynamics. Okay, but here what it means, that one molecule of enzyme can catalyze millions of reactant molecules, right? One enzyme can catalyze millions of reactant molecules. There is no need of equal number of enzymes as that of reactant. It is not like that कि one enzyme can catalyze one reactant. It can catalyze millions of reactant per second. That is efficiency of the enzyme. Okay. Then third, small quantity. Obviously, if it is highly efficient, a small amount of enzyme, small quantity of enzyme is enough to do the whole process. Okay. Small quantity of enzyme is sufficient to carry out whole biochemical reaction or biochemical process. Okay. Then optimum temperature and pH. So, what do you mean by optimum first? Tell me. What do you mean by optimum? Optimum temperature, optimum pH, मतलब क्या है इसका, पहले ये बताओ. चलो. हाँ वो ठीक है, मुझे बताओ ऑप्टिमम का मतलब क्या है. ऑप्टिमम बोलते हैं ना, ऑप्टिमम टेम्परेचर, ऑप्टिमम पीएच. First, optimum means what? It is like this. That it is maximum efficiency, rate versus temperature. If you plot the graph, or rate versus pH, if you plot the graph, then it is like this. Means at a particular temperature its rate is, at a particular pH its rate is maximum. Above it, below it, rate is less than the optimum temperature. Rate is less, more than that, or less than that, less than the optimum pH. So optimum pH for enzymes is 7.4 and optimum temperature is body temperature, that is 37 degree Celsius. Means at 37 degree Celsius enzymes has highest efficiency. At 7.4 pH it has highest efficiency. Below that pH, above that pH, they are not doing the things at their maximum capacity. That's what optimum means. समझिए बात को. ये मैंने ग्राफ भी इसलिए बना दिया उसका, ठीक है. हाँ, वेरी गुड हर्षिल. ह्यूमन बॉडी टेम्परेचर फॉर एंजाइम, हाँ, means temperature or pH at which it works best. Below it, above it, क्या हो जाता है उसका जो एफिशिएंसी लेस. ठीक है, इसलिए ग्राफ दोनों रखना है. कभी भी ऐसे ग्राफ दिखे रेट वर्सेस टेम्परेचर, रेट वर्सेस पीएच, तो समझ लेना दे आर बायोकेमिकल प्रोसेसेस. दीज आर द ग्राफ्स फॉर बायोकेमिकल प्रोसेसेस. ओके, नाउ then enzyme activators. कितने पॉइंट होते? 5. और क्या बोलते हैं उनको? coenzymes. What is the work of these activators or coenzymes? They increase the efficiency, enhance the efficiency of the enzyme. Non-protein part because enzymes are proteins, right? Non-protein part which enhance the activity of catalyst or of enzyme are called coenzymes. These are vitamins. Coenzymes are actually vitamins. Okay, and some metal ions can act as activator. बता सकते हो? Metal ions like sodium ion, Mn2 plus ion, even copper 2 plus ion, cobalt 2 plus ion, etc., which when attached to enzyme their activity is enhanced. Are called activators. Okay, now enzyme inhibitors or inhibitors are called catalytic poisons. Inhibitors or poisons. तो ये क्या करेंगे? They slow down the activity of enzyme. कैसे करते होंगे? By attaching, by blocking. their active sites. So most of the drugs are enzyme inhibitors or catalytic poisons, right? So these are the characteristics of enzymes. Now, mechanism of enzyme catalysis. How it catalyze the reaction? Actually, just like हमने एब्जॉर्प्शन में पढ़ा था, enzymes जो होते हैं they have active sites. Enzymes have active sites. So enzyme की जो active sites होंगी उनकी क्या होगी, पर्टिकुलर शेप होगी और पर्टिकुलर साइज होगा, राइट, एंड have some functional groups. और उनमें क्या होते हैं साथ में functional groups. जो एक्टिव साइट्स होती है वहां पे फंक्शनल ग्रुप होते हैं लाइक COH, NH2, OH, SH, etc. कोई फंक्शनल ग्रुप्स होते हैं ना. So these functional groups, when a reactant comes closer to active site, these functional groups hold it tightly and adjust in the active site. And when it is adjusted in the active site, that will react and form the product. And product has no affinity for that active site. So product goes away. That is the mechanism. First we have enzyme. Enzyme has active site and substrate is the one which is complementary to lock and key model. We are talking about lock and key model. That for particular lock there is a specific key that can open the lock. Other key cannot. Okay. So enzyme and substrate form enzyme substrate complex, and then enzyme substrate complex breaks to give back enzyme and we get the product. This is step 1 and this is step 2. So diagrammatically it can be written as suppose we have enzyme like this. Okay, so substrate should be okay. I am very poor in drawing all this. Okay, I will write a very simple diagram. should be like this. Okay, so when this enzyme comes in contact with substrate, so it become sorry, but it is like that when they come in touch with each other, and then substrate react and we get product. Okay, like if it breaks, like this part remains as such and other part breaks. Let us take this one first part and other part. So two parts are formed. This is product and this is, we get back enzyme. Okay, means enzyme and substrate have complementary shape. Okay, so they will join to form enzyme substrate complex, and then substrate give product and regenerate enzyme. That is the mechanism. Okay, done. Okay, now catalysts used in industry. Do we have time? Yes. So last topic of the day, catalysts used in industry. Okay, so first is Haber process. Yes, tell me, Haber process is used for what? करो, ये तो हेबर प्रोसेस तो आपने अच्छे से किया हुआ है. बोलो हेबर प्रोसेस में क्या क्या होता है? हेबर प्रोसेस में N2 gas react with 3H2 gas to give 2NH3 gas. In this case, iron solid act as a catalyst and molybdenum act as promoter. Okay, and temperature, I think it is temperature and pressure 723 to 773 Kelvin temperature and 200 atmosphere pressure. So Haber process is used in industry where we use iron as a catalyst, molybdenum as promoter. Okay, now next one is Ostwald process. First tell me, for MO is molybdenum is used as promoter. Ostwald process is used for what? बोलो, Ostwald process किस लिए यूज होता है? किस प्रोसेस में यूज होता है? बोलो जल्दी. Ostwald process is used for what? जल्दी. ये मुझे लग रहा है गूगल में सर्च करने लगते हैं. Don't search Google if you know, then it's okay. otherwise I will let you know. Okay, so it is used for nitric acid actually. Ostwald process is used to prepare nitric acid. तो इसमें क्या होता है, फर्स्ट ऑफ ऑल अमोनिया, it is oxidized in the presence of platinized asbestos, ठीक है. It is used as a catalyst, okay, to give NO along with H2, okay, NO and H2O. अब मैं बैलेंसिंग आपको सिखा नहीं रहा हूँ, सीधा नंबर लिख रहा हूँ. It is 4, 5 है ना, तो it is 4 and 6. Then जो NO बनेगा, NO is oxidized by O2. NO is oxidized to give NO2 gas. NO to give NO2 gas, ठीक है. And after getting NO2 gas at 573 Kelvin, NO2 gas जो है उसको फिर हम वाटर में डाल देते हैं. So NO2 gas को वाटर में डालेंगे and then it is oxidized, so we get HNO3, nitric acid मिलता है in the presence of air and water, right? So balancing कर रहा हूँ मैं, it is 4 and then 2 and we get 4 HNO3. So this liquid is formed. So Ostwald process is used to prepare nitric acid and platinized asbestos is used as a catalyst. Here iron and molybdenum. Iron as a catalyst, molybdenum as a promoter. Okay. Next is contact process. Yes. Anybody know contact process? Contact process. Very good, Harshil. Contact process किस लिए यूज होता है? Very good. H2SO4. Good. तो इसमें क्या होता है, पहले जो SO2 गैस है, ठीक है, it reacts with O2 gas to give SO3 gas. So in this case even we can use platinized asbestos or we can use B2O5 solid. ये उसमें भी करवाया था मैंने आपको, heterogeneous catalysis. Same is used in heterogeneous catalysis. SO3 gas is formed and then SO3 gas, देखो SO3 gas को डायरेक्ट वाटर में नहीं डालते because that is highly, wait 1 second. गुनगुन, 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 हेलो, क्लास चल रही है बेटा, इतने जोर जोर से बोल रहे हो यार. ओके, सॉरी. SO3 गैस को मैंने क्या बोला आपको, डायरेक्ट वाटर में नहीं डालते हैं, तब भी सल्फ्यूरिक एसिड तो बन जाएगा क्योंकि SO3 plus H2O it gives H2SO4. बट उसमें क्या होता है, रिएक्शन इज हाईली एक्सोथर्मिक, तो उससे वो सल्फ्यूरिक एसिड के फॉग बन जाती है, सल्फ्यूरिक एसिड के फ्यूम्स बोलते हैं, हाईली क्रोसिव होते हैं, बोलते हैं सल्फ्यूरिक एसिड तो मतलब हाईली डेंजरस है, पूरा पूरा फैल जाएगा वो पूरे रूम में ही, है ना। इसलिए पहले क्या करते हैं, SO3 इज डाइजेस्टेड इन सल्फ्यूरिक एसिड टू फॉर्म ओलियम। क्या बनाते हैं, ओलियम, H2S2O क्या देगा 7, दिस इज कॉल्ड ओलियम। एंड देन उसको फिर हम वाटर में धीरे धीरे डालते जाते हैं ओलियम को। तो दैट इज द प्रोसेस फॉर द फॉर्मेशन ऑफ सल्फ्यूरिक एसिड बाय कॉन्टैक्ट प्रोसेस। ओके, डन। देन और कोई करना है, चलो, हाइड्रोजनेशन ऑफ वेजिटेबल ऑयल। सो ऑयल्स क्या होते हैं, अनसैचुरेटेड फैटी एसिड्स, अनसैचुरेटेड होते हैं ना ऑयल्स, तो उनकी हाइड्रोजनेशन करते हैं तो वी गेट वेजिटेबल फैट। ठीक है, तो देखो वेजिटेबल ऑयल, ऑयल क्या लिक्विड, और उसको हमने क्या किया, H2 गैस की प्रेजेंस में क्या बना दिया, फैट, राइट। वेजिटेबल घी, डालडा घी, है ना। ओके, तो इसके प्रेजेंस में होता है, इट इज फाइनली डिवाइडेड निकल, इवन प्लेटिनम, प्लेटिनम भी यूज कर सकते हैं, है ना, एट 423 to 473 केल्विन टेम्परेचर। ओके, सो इतना ही करो। दीज आर द कैटलिस्ट यूज्ड इन इंडस्ट्रीज। और आप कोई भी ले सकते हो, बहुत सारे एग्जांपल्स हैं, बट ये जो सारे हैं दे आर इन आवर क्लास 12 सिलेबस। इसलिए सल्फ्यूरिक एसिड आएगा आगे, नाइट्रिक एसिड बनाने के लिए आएगा पी ब्लॉक एलिमेंट्स में, ठीक है ना। फिर हेबर प्रोसेस भी पी ब्लॉक में आएगा, है ना। उसमें बहुत सारे रिएक्शन आएंगे जो कि इंडस्ट्रियल यूज है, तो वहां से भी ले सकते हो एग्जांपल। सो दिस इज ऑल अबाउट सरफेस केमिस्ट्री। वी हैव डन all the things related to surface chemistry. Now we will start next chapter. Before going to next chapter, we will cover its exercise. So in the next lecture, you should learn all the things of the exercise, and I will ask one by one. Okay? Done. So, okay, thank you very much. तो अब ऑर्गेनिक करनी है, आई हैव नो प्रॉब्लम एट ऑल। अगर ऑर्गेनिक करनी है, ओके ओके, थैंक यू। तो मुझे ये बताओ, अगर ऑर्गेनिक करनी है, मैं पूछ लेता हूँ सबको, इफ यू आर इंटरेस्टेड टू गो फॉर ऑर्गेनिक, आई हैव नो इश्यू एट ऑल। तो क्योंकि 5 चैप्टर अपने हो गए, अपना फिजिकल वाला पोर्शन कवर हो गया, तो फिजिकल हो गया, ऑर्गेनिक करो इनऑर्गेनिक करो, इट इज अप टू यू। बट ये होगा कि ऑर्गेनिक एक बार स्टार्ट किए तो वी शुड गो अप टू द एंड। ऑर्गेनिक पूरी कंप्लीट करनी पड़ेगी, मतलब पूरी सेकंड बुक। उसमें मत बोलना कि वापस आओ जी पी ब्लॉक में, वापस आओ इनऑर्गेनिक में, फिर इनऑर्गेनिक लास्ट पोर्शन रहेगा हमारा। ओके, सो एक लेक्चर फिजिकल अपना कंप्लीट हो गया, है ना। तो वी कैन स्टार्ट ऑर्गेनिक नाउ। ओके, डन। सो वी विल स्टार्ट ऑर्गेनिक इन द नेक्स्ट लेक्चर। डन, चलो जी, बाय बाय। फिजिकल का सॉरी सरफेस केमिस्ट्री की एक्सरसाइज करनी है और वो आपको करके लानी है। मैं आपको सिर्फ क्वेश्चन पूछूंगा, आप मुझे आंसर दो। मे बी वी विल शिफ्ट टू सम ऑडियो विजुअल, ठीक है। इसमें नहीं हो पाएगा ओरल टेस्ट लूँगा, तो हो सकता है ये जूम में या गूगल मीट में कुछ करते हैं ऐसा, है ना, ताकि मैं बोलूँ और आप फिर आंसर दो एक एक करके, जिसको मैं अनम्यूट करूँ वो बोलेगा, ठीक है। कल कौन सा डे है? नहीं, कल कल तो नहीं कर लेंगे लेक्चर, है ना, संडे और मंडे, ठीक है ना। ठीक है, बाय बाय।